We're going to walk through solving a Sudoku puzzle from beginning to end, but before we get started, I want to make a couple comments. This video is for people who are new to Sudoku. The puzzle is quite easy and there are many pathways to get there. If you have even a small amount of experience, you could probably solve this on your own. My only goal here is to demonstrate the logic discussed in the previous videos. That said, to keep the video at a somewhat reasonable length, the logic will be explained quickly and visualizations will be used to help communicate what's happening. If anything happens too quickly, you can always go back and listen to the logic and pause to give yourself time to think about it. The process I'm using here is systematic for the purposes of being systematic. On the left, you'll see that I'll work through positional elimination first, followed by value elimination, working through the boxes in order. Typically, you won't work through the steps quite as mechanically as I do here, as you'll be making observations that give you ideas for how to make progress. I'm doing it this way because this systematic approach is what I fall back on when I'm feeling stuck, in order to make sure I'm not missing anything simple before I start looking to use more advanced concepts. And with those comments out of the way, we can begin. We'll start by looking at the ones. To help visualize things, we'll circle them. In box 1, we see that 1 is forced in the bottom right corner. And in box 8, we can reduce the 1s to just 2 positions in row 7, so we use corner marks. These 2 corner marks line up to eliminate 1 from row 7 in box 9, and that gives us another digit. And this gives us a couple corner marks in box 6, and that's all we can do with this digit for now. Moving on to 2s. The 2 in box 3 gives us a 2 in box 2. And these 2 2s give us corner marks in box 1. We can also get corner marks in box 8. Next are 3s. We already have 5 of these. We can get the 1 in box 3 and box 7 right away. Then in boxes 4 and 6, we have an X-wing of 3s. This X-wing doesn't actually accomplish anything for us because we already have all the 3s in the other boxes, but it's helpful to observe the pattern. And now on to 4s. We immediately get 1 in box 3 and in box 7. We can get an X-wing of 4s in boxes 5 and 6. Unlike the previous X-wing, this one gives us another digit in box 4. The X-wing eliminates rows 4 and 6, and the 4 in box 7 finishes it off. And that digit helps us to get the 4 in box 1. If we look back at box 6, we can see that the corner marks for 3 and 4 are in the same 2 boxes. We can use either box logic or column logic to convert them into center marks, giving us a 3-4 pair. There's not a lot we can do with the 5s. We can get a pair of corner marks in box 3, and those corner marks eliminate 5s from column 8 in box 9. For the 6s, we get digits in box 2 and box 9. But the 6 in box 9 replaces a corner mark 5, which means that there's only one corner mark 5 left in the box, and so we get an additional digit. After that, we can get a pair of corner marks in box 1 and then in box 6. There's a lot going on with the 7s. We get a 7 in box 2, which gives us a 7 in box 3. That 7 eliminated a corner mark 5, so we also get a digit 5 in box 3. Then we get the 7 in box 4 and box 9. And now we have 9 7s, so we're done with that digit. Now 8s. We get the 8 in box 1, which also gives us the 2 from corner marks. We get a pair of corner marks in box 6, which we can convert to a center marked 6-8 pair. Those marks eliminate column 8 in box 9, which helps us to get an 8 there. The last digit to check is the 9s. We get a 9 in box 1. we get corner marks in box 6, which give us corner marks in box 5. Lastly, we get another pair of corner marks in box 7. We now move on to eliminating by values, starting from box 1. There are only 2 empty cells in this box, so we can fill them in with center marks. At this point, we can look through the rows and columns for 5s and 6s to see if we can make any further progress. Technically, we'd only need to look at the columns in this case because the center marks are lined up in a row, but you get the point. We're just looking for information to help us finish these cells, and in this case, there isn't any. Box 2 has only 1 empty cell, so we can just fill it in by seeing what value is missing. The same is true of box 3, and this completes those 2 boxes. Box 4 has 5 empty cells, so we will look at rows and columns to try to make progress. Column 3 has only 2 missing cells, so we can create center markings. We now have a 3-5 pair, and there are only 3 empty cells in the box. We can fill it in as a 1-2-6 triple, and then look for eliminations from there. Row 6, column 1 can see both a 1 and a 2, so this cell must be a 6. This 6 and the same 2 from before mean that row 6, column 2 is a 1. And this means the center cell in box 4 must be a 2 because it can't be a 1 or a 6. Box 5 doesn't give us a lot to work with. We can put a 1/8 center mark in the center square, and that's about it. Box 6 has some center marks that we can work with. The 6 at the left of row 6 means that the bottom cell must be an 8. This forces the center cell to be a 6. Solving that digit means that row 5 only has 2 unsolved cells, and we can determine that the right cell must be a 1/8 center mark. But we just wrote an 8 in this box, so this forces it to be a 1. For the last 2 empty cells in the box, we see that it must be a 2-9 pair. And then the cell in column 9 sees a 9, making that one a 2, and that makes the other one a 9. Box 7 has only 3 empty cells, and we can see that these must be a 2-5-9 triple. We can see that there's already a 2 in column 2, which eliminates 2 as a possibility from those 2 cells, making it a 5-9 pair. And that forces the cell in row 8, column 1 to be a 2. For box 8, we can look down column 5 to see that it can only be a 1 or an 8. In this case, we're getting that information from the 1/8 center mark in box 5, and the fact that only 2 cells in this column are unfilled. If we look in box 8, we can see that there's an 8, so this cell must be a 1. And now there are only 3 empty cells in the box, and we can fill them with center marks. These form a 2-5-9 triple. In column 4, there's a 2 at the top, so the 2-5-9 center mark becomes a 5-9 center mark. And now if we look at row 7, we can see that there is a 5-9 pair, which makes the cell in row 7, column 6, a 2. Lastly, the 2-5-9 in the bottom right corner is reduced to a 5-9 center mark. And now we move to box 9. Looking at column 8, we have 8 digits filled in, which means that the missing digit is a 2. And now the box has 8 digits filled in, which means that the empty cell must be a 9. At this point, we can continue to be purely systematic, but we have so much of the puzzle completed that it's more instructive to follow chains of inferences. This is more typical of how solves will play out. If we look at row 9, we see a 5-9 center mark and a 5 in the corner. That means the center mark square must be a 9. And that 9 forces the other center marked 5-9 in the box to be a 5. That 5 sees a 5-9 center mark in row 7, column 2, which forces that cell to be a 9. That one sees the 5-9 just below it, turning it into a 5, and that 5 sees the 5-6 at the top of the grid, forcing that one to be a 6. Then that 6 sees a 5-6 center mark next to it, forcing it to be a 5. And that is the end of that chain of inferences. All of the new digits we wrote down in this chain are circled, and you can see how they are linked together through boxes, rows, and columns. It turns out that the 9 that started off this chain is also at the start of another chain. If we look at box 5, we can see that there's a pair of corner marked 9s, and that 9 sees one of them. This forces the other one to be the location of the 9. But filling in that box eliminates one of the corner marked 4s, which means that we can also fill in that digit. Looking across row 4, the 4 we just wrote down sees the 3-4 center mark in column 7, forcing that cell to be a 3. The 3 sees the 3-5 center mark in column 3, making it a 5. That 5 sees the 3-5 a couple cells below it, making that one a 3. And we can also see that the 3 in column 7 forces row 6 to be a 4. Lastly, we just have to finish off box 5. Row 4 tells us that the top right cell must be a 1. That sees the 1/8 center mark in the middle, making it an 8. Then we can look at the box and see that 5 is the only remaining digit, and now we have completed the whole puzzle.